Saponification by Ella Hilbrecht. So we're going to be reacting sodium hydroxide with water and then that with coconut and olive oil. I'll be walking you through the steps this takes. Sodium hydroxide, once mixed with water, will become an aqueous solution since it'll be fully dissolved, and it'll be exothermic. So we'll add that solution with fatty acids as well to create our saponification reaction. Sodium hydroxide will be added with the fatty acids. In this case, it'll be coconut and olive oil, both of which will have different sap values, refers to 1 NaOH per 1 gram of oil. We need to have a full saponification reaction. Coconut has a higher sap value since it is a solid at room temperature. Why do we have soap and why do we use it? So once we have soap crystals formed, what they do is they have a hydrophilic head and a hydrophobic tail, and so they will surround oils and fats, and then this will lower micelles, which are pretty much bubbles. This will lower surface tension, allowing these fats to be washed away. So what's the pH throughout the saponification reaction? We're reacting water, a pure liquid, with sodium hydroxide, a very strong base, and so the resulting solution will be very basic. And this will also be exothermic as well. Once that's fully dissolved, we're going to add it to coconut and olive oil in a liquid state, and this is where saponification will start. So saponification, once the oils and the sodium hydroxide are mixed, the triglycerides and the oils will cleave, leaving the glycerol and the fatty acid tails, and so this will help form our soap molecules. Here we have our triglyceride. So with the addition of sodium hydroxide, it separates into the glycerol backbone and then the sodium oxalate, which will be our soap molecule. The mechanism for that is that we have the glycerol and the NaOH. It'll be cleaved. So what is the mechanism for the soap crystals being formed, or the salt or the fatty acid being formed? So we have our triglyceride and our sodium hydroxide. Once the sodium hydroxide is added, it will be cleaved into our glycerol backbone and our soap molecule. So the mechanism for that is that the ester on the triglyceride will be reacting with the base hydroxide, resulting in an intermediate where they have an alcohol group, and carbon can only have 4 bonds, and so eventually the double bond between the oxygen and carbon will reform, and resulting in the fatty acid chain becoming the leaving group, leaving a carboxylic acid and alkyl oxide. Then we go through deprotonation, where the carboxylic acid will form another double bond with the O, and resulting in 2 electrons on the oxygen and an alcohol group. This process is a nucleophilic substitution reaction, where the hydroxide ion replaces the fatty acid chain, forming soap molecules. So why did we use sodium hydroxide instead of potassium hydroxide for creating soap? Sodium hydroxide produces hard soap, meaning it's good for lathering, and also is good in water that has a lot of minerals. Potassium hydroxide produces soft soap, also has a lower melting point and weaker intermolecular forces, and so it is used up a lot quicker. So as you can see, the first step I'm taking in the saponification reaction is setting up our oils. So I am heating up coconut and olive oil to the same temperature and allowing it all to melt so that it'll react well with the sodium hydroxide solution. I'm using wooden spoons because metal's conductive and I'd rather not burn my hands since all of these are very exothermic. Here I'm prepping the ice bath to cool down the sodium hydroxide exothermic reaction with the water. I'm covering my mouth and nose a lot with the sodium hydroxide and water reaction because it gets so hot that it emits vapors and it can be quite irritating for your nose. So once you react the sodium hydroxide with the water, you're going to keep mixing until it's all fully dissolved, and then once you see it's pretty dissolved, you're going to put it in this ice bath and you're going to monitor the temperature until you add it to the oil. So here I've mixed them, and this is the start of the saponification reaction. As you can see, it's gone from clear oils to a bit of a milky color. This is because we're forming our soap. So I switch pretty quickly to a hand blender to help get a quicker trace. So once we reach trace, we can add our colors and dyes and fragrances. We add fragrances after trace because otherwise, since they're an acid, they'll react with the base and you pretty much won't be able to smell anything once the soap has hardened. So here I've added some mica, and I'm going to be adding in some fragrance as well. Since we're doing the cold process version of soap, there's also a hot process version. The hot process is where you use the very hot sodium hydroxide and water solution, and once that is dissolved, you mix it when it's still really hot with the oils before they're melted. In this case, we've done the cold process where we do it separately and then add them, and we do this because I have a longer curing time, but it allows me to have more time with the soap, so I'm less likely to mess anything up and I have more time to make sure what I'm doing is correct. So now I've reached a hard trace. As you can see, you can have the outline on the top of the soap.